Today's lecture is about moles and how to use it. And when I first learned about moles, it was kind of strange because moles was this number, Avogadro's number, 6.02 times 10 to the 23rd, but it was also a mass, and we were always talking about grams and moles together. So the thing to think about from the beginning is that a mole is a number, just like a dozen means 12. But when you have a mole of something, it has a mass. Just like if you have a dozen donuts, it has a mass. If you have a dozen eggs, it has a mass. And those two masses are not the same between eggs and donuts. So we have the same thing true with different molecules, that we can have a mass of a mole of molecules, but that mass is different depending on what kind of molecules you have. So anyway, a dozen is 12, just like a mole is this big number. And this is Avogadro's number. Okay, and we use this big number to count molecules because molecules are so small. And so when we talk about having a mole of something, 1 mole of molecules is this number of particles. Also, we use the word mole for counting molecules or atoms or numbers of ions. So any kind of particle. So anytime you see we talk about molecule, it could be an atom or whatever it is we're counting. Okay, so we know what a mole is in terms of numbers. Let's connect that to the mass. And molar mass, and this is how we show it, it is the mass associated with a mole of particular atoms or molecules. And like I said, that mass depends on what the molecules or atoms are. Just kind of like when we count 100 dimes, that may have 1 mass versus 100 quarters that has a different mass. So molar mass, it represents how big the molecules are. So the units for molar mass are grams per mole. And again, this number here, the number of grams, depends on the size of the particles. To get a molar mass, we just use the periodic table. So we get a conversion factor between mass and number of molecules just right off the periodic table. So to get the atomic weights are these lower numbers down here. Remember, we said before we weren't using those. Those are not mass numbers. These are atomic weights, and you just add them up for the compound that you're interested in. For example, let's look at the molar mass for NH3, which is ammonia. So you need to add them up. There's 1 nitrogen here, and if I look, nitrogen's atomic weight is 14. Plus, I have 3 hydrogens here. So if I look on this one, it's 1.01 for hydrogen. Sometimes we just have 1.0 for hydrogen, and that's fine. Just follow your sig fig rules when you add. I'm not really picky about that. So let's label this. This is nitrogens, and this is my hydrogens. And so I add that up. And when I add that up, what happens is that 1 gets dropped because of the add rule. Anyway, when I get my molar mass of my ammonia, this is going to be in grams per mole. And it's important that you understand that the number goes with the grams because this is a conversion factor, and we'll need to always make sure that number is with the G. So let's look at how we can do some calculations with this. and these conversions. This is our main topic. So now we have a way to get from grams to moles, and that is the molar mass. It has 2 units, a top and a bottom, and it will let us get between. We also have a conversion factor to get between the number of moles and the number of molecules. And that is Avogadro's number. If I want to know how many moles is 25 grams, so I have one number that I'm going to start with. And by the way, you'll never start with the conversion factor because both of them have a top and a bottom, 2 units, so you won't start with them. I'll start with my other number, my 25 grams. And then I'll let my units do the work. I'm going to put grams down here so that it will cancel. And then I'm trying to get to moles, so I'm going to put moles up here. And then let's consider the conversion factors we have. I have a conversion factor that goes between grams and moles right here, the molar mass. So I'm going to use the molar mass of NH3, which we calculated above. It was 17 grams per mole. Take off my S. And I get, this is what my calculator says, but I have 3 sig figs, so I'll have 1 point. And that's my answer. So this is how you use this little map that you kind of can see where you're at. And this is, yeah, I don't want you to memorize this map. This is to kind of help guide you as you're starting so that you get a feel for it. But you can look at where you're starting and see where you're going to go next. If I start with grams, I can go to moles using molar mass. And then if I need to go to number of molecules, I'll use Avogadro's number on my next step. So kind of pay attention to how that's kind of a map of how you get from one place to another. Let's do one more. Okay, what is the mass of 5 molecules? Well, let me just kind of, if this were thrown into an exam somewhere and you've got to figure out, well, where do I start? 2 things. One is that in chemistry, molar mass is always a conversion factor that you might know if you know the formula, which we do. So let's write down our molar mass, which we already determined. And then the other thing is when I see a problem that involves the number of molecules, the only thing in chemistry that we have that involves counting or number of particles is Avogadro's number. So I'm going to go ahead and write that down because I might need that. Okay, so there's 2 tools that I might need. Now let's, I don't have an equation for this, so I'm going to approach it with a conversion factor type method. And then what number do I put here? Well, both of these in purple that I came up with are conversion factors. They have 2 units. And so I need to watch carefully. I have another number there. I need to be careful about abbreviating molecule because if I do, it might look like mole, and that will really throw things off. The other thing is that when I write out a number like this, this is exact. So as far as sig figs go, I have exactly 5 molecules. Okay, then I want to figure out what to do next. So I see molecules up there, so I'll put molecules here. And then what should I go to next? Well, if I look at my conversion factors I came up with, this one has molecules in it. So according to that, I can go to moles. And if I need to make sure I put the number with the right one, it goes down here. And it's 1 mole. Okay, and then just following my rules for sig figs, or my rules for the conversion factor method, I got rid of molecules. I see I need to have moles down here so that it will cancel next. And if I look at my things, I have a conversion factor now that will take me to grams. I need to make sure the 17 stays with the G. It always goes with the front one. And then I have a 1 down there. And now my moles will cancel and my answer will be left in grams. On these problems, sometimes you can really look at it and see if it makes sense, and you really should, because it's easy to mess up on Avogadro's number. So what I would say is, I'm talking about the mass of 5 molecules. Molecules are tiny, tiny, tiny. And so I would expect what kind of mass? I would expect a really small number. And you can see here, I didn't get a really small number. I got a big number. And so that's why I was saying you can check yourself. This is wrong. I just looked at my calculator really quickly and I missed the negative sign. So that's really what it is on my calculator. So I caught it. You can also do this the other way, where you're given a mass in grams and you're calculating a number of molecules. If you're given a mass in grams that's like a reasonable number, not some tiny, tiny number, but like 50 grams or 10 grams or something like that, and you calculate the number of molecules, you're going to expect to get a huge number. So another one to kind of watch for. And that's it. That will get you going on these calculations using molar mass and Avogadro's number.